Antes que nada, comentar que yo no soy Carmelo Santana, el gerente del Consejo Insular de Agua. Soy un compañero del Consejo, un técnico, jefe de sección. Carmelo ha tenido que ausentarse por un tema de juntas de gobierno en general, que es imprevisto y las han convocado para esta tarde y por lo tanto pues, se incorporará un poquito más tarde. La primera de las ponencias, que va a ser a cargo del ingeniero Volkmar Keuter, jefe de Departamento de Medio Ambiente y Recursos en Fraunhofer UMSICHT, va a estar titulada Innovación y tecnologías para la mejor utilización de los recursos naturales, agua, agricultura y alimentos. El ponente estudió Ingeniería de Bioprocesos en la Universidad de Ciencias Aplicadas de Berlín, Ingeniería Mecánica en la Universidad de Essen. Ha desarrollado su vida profesional en empresas como Lurgi, Australia, en Bicon, Düsseldorf y MNT System en Oberhausen. Hasta el momento actual, donde es responsable de la implantación del proyecto InFarming, plataforma de desarrollo tecnológico para un mejor uso de los recursos, energía y agua y fertilizantes en tiempos de cambio climático. Esta ponencia va a ser en inglés, por lo tanto están a su disposición las petacas de traducción, que entiendo que el que quiera puede, en la parte de atrás, el que quiera usarlas puede solicitarlas. Muchas gracias y dejo la palabra al ponente.
Yes, thank you very much, Mr. Chairman, and thank you for the opportunity to have an insight for you on some of our technologies we are developing at Fraunhofer UMSICHT. I hope it's fine for you that I'm just speaking English. My Spanish is very, very bad, so I hope that's also okay for you. So Fraunhofer UMSICHT is a research institute directly in Germany, situated in the western part of Germany, and Fraunhofer Society comprises more than 70 institutes all over spread in Germany, and all together we have around 30,000 employees in all institutes. And what we are doing at Fraunhofer is doing very much applied research. So we're going very close to the market with our developments. Fraunhofer UMSICHT itself, around 600 employees at 3 locations in Germany, and at Oberhausen we are mainly process engineers, chemical engineers, and I myself am very dedicated to wastewater and water treatment technologies. So I will give you a glimpse on what agriculture is facing in Germany and most parts of Europe. And if you're looking to the emissions of agriculture, so a lot of the manure and fertilizer spread in the environment is going directly to the groundwater. There we see problems with nitrates and other emissions which faces further treatment processes before you drink it as drinking water in our households. And of course, Germany and Europe is facing dramatic changes in climate. That's a picture of the Bodensee, the largest lake in Germany in summer 2021. And you see a lot of water is disappeared. And this topic is very dramatic in most countries in Europe. That's a quite present picture of 2022, where you see very heat degradation in Europe all over the countries. And for the agriculture prospect, this has a dramatic change, and also a dramatic change in different crops which we can grow or even not grow because of the water. I'm sorry. So the change of the global food system is another parameters we are facing in Europe. And you see that most of the people in 2050 are living in cities, in urban areas, in bigger metropolitan areas. For Germany, that's not a big problem, because compared to the UN, we don't have that big mega cities in Germany. But of course, people are change their living place into cities. And the sustainability, 70% of the drinking water worldwide is used for food. 70%. And concerning the climate change, that will have dramatic influence on how we get feed and food from our land, from our soils. And we also see customer changes. In Germany, a lot of customers are very faced to local foods, to organic foods. And this has also impact on our farmers. So if you have a look on different cultivation systems, one is the field cultivation, quite traditional, and we have greenhouses. You also have on the Canaries greenhouses, and the most highly efficient cultivation system, so-called controlled environment agriculture, means indoor cultivation. And I will want to face you the look on, that doesn't work, on the yield. If you have a look on the yield, just for lettuce, you can have 100 times higher yields from the field to the indoor cultivation systems. But you have to buy it with energy because it's a closed environment. And if you want to have this high yields, you have to put light and air conditioning in these indoor cultivation systems. And of course, the cost for such cultivation systems are even higher at a factor of 1,000. But highlighted on the second last row is the water efficiency. And if you talk about water for agricultural systems, these systems can be cycled, and you don't have nearly only 2 to 5% water losses in the whole system compared to field cultivation, where it goes directly into the soil. And if you're thinking of such highly degraded, cultivation systems, you usually talk about hydroponic systems and aeroponic systems. Hydroponic systems, cultivation system without any soil, and you make the cycle of the nutrient solution and the water. And even more sophisticated is the aeroponic system, which uses just small droplets to put it directly to the plants. And there the water efficiency is nearly 98%. Hydroponics, about evaporation, 95%. And just a few examples of what you can cultivate in those systems. Pictures of lettuce and herbs, what we are cultivating in hydroponic systems. That's not very sophisticated. A little bit more sophisticated is cultivation of sugar beets in hydroponic systems. And they are comparable to those plants cultivated in soil. So that's very interesting, and even more crops are possible thinking of cultivation systems of cultivating in hydroponic systems. And sweet potato, that's also possible. That's not so easy. We cultivate this with colleagues of the Hochschule Osnabrück in aeroponic systems. And you see that on the lowest picture over there, that the roots are very small still. But we are getting further, and in a short time, those roots will be the same size than usual cultivated sweet potatoes. And not only food is thinkable to be cultivated in such indoor systems, but also healthy plants, pharmaceutical plants, like arnica, which is used in cosmetics, or also in pharmaceuticals. And that's very interesting because a lot of problems in those countries where they are cultivated in the moment and further processed in German chemical industry are associated with quality aspects and also with aspects of using any kind of chemicals. So what we developed more than 12 years ago now is a kind of concept or R&D platform where we can cultivate very close to the point of use. That might be we as consumers, or that might be the industry for further processing. And we are concentrating on different R&D pillars. The integrated fertilizer production and the sensor development, I will go a little bit more deeper in. So in 2019, we opened up our platform Altmarktgarten right in the center of our hometown in Oberhausen. It's a cultivation area of around 1,300 square meters, divided in 4 research pillars. And the very special is that we close the loop between the building and the greenhouse on the top. That means waste heat for cultivation in the northern hemisphere. Also 365 days you need heat. And we use also carbon dioxide from the building below, and we use the nutrients from the building below. So that's, for us, very highlight. But we are not alone. So different projects in Europe are going the same direction. On the open left side, that's a building directly on the roof of a supermarket. It's controlled by a food company and opened up in 21. Currently, the same technology is used in Belgium, in Brussels, and here we have a location in Copenhagen, in Denmark. That's complete vertical farming on 7,000 square meters. So quite interesting. And if you look worldwide, I think everywhere they are spreading such cultivation systems, completely controlled, because the yield is very high. And this one in Japan, in Kyoto, they have a yield of around 30,000 lettuces per day. So that's more like a factory. But for Japan use, it's very interesting. And they have control systems, they are using light, they are using nutrient and water efficiency, so that's very nice. So I want to give you a small glimpse of fertilizer recycling. So if you're looking to the worldwide use of NPK, so nitrogen, phosphorus, and potassium fertilizers worldwide, it's an enormous amount, 104 million tons of nitrogen, around 50 million tons of phosphorus, and of course, potassium you also need. And the phosphorus is not a recoverable resource from nature. So we have to get back into phosphorus recycling, either from wastewater streams or from different sources. And what we are doing in Oberhausen now, we're closing the loop between a wastewater treatment plant and a food production system, because it makes sense. Because nearly all the resources you need for cultivation systems, like all fertilizers, all nutrients, and you have heat and you have carbon dioxide, you find on a wastewater treatment plant. So just eliminating all the nutrients from traditional wastewater treatment plants will not be the future, I'm very sure. Because also the legislation is going into this direction. In Germany and in Europe, we will have to recover phosphorus from wastewater treatment plants. And the process is quite difficult, depending on different process steps. Mainly, it's a combination of biological treatment and membrane treatment processes. And we have to adapt different micronutrients and also the ratios, because the hydroponic fertilizer have different necessities. And what we get is a liquid fertilizer, which is by now very high, produced by, according to the regulations of the heavy metals in the fertilizer regulation. So we nearly don't have any heavy metals in the fertilizer. And as a second, if you're thinking on wastewater, you always have to think of chemicals, micropollutants, and also there, our fertilizer, until the whole process to the production, does not have any micropollutants in. So that's very safe for the consumers. What else are we doing? We are very much confirmed also with sensor technologies, with sensor competences. That's an example for having a look to dynamic measurements of plants, so that they get directly into the process, or the cultivation process, the content of any kind of inhabitants, like vitamin C or anything else. But what we also do is thinking on energy consumption in those indoor cultivation processes. And if you think on cultivation process, a lot of the knowledge is historical based, and it's based on our brains and on the competences of the man behind. So what we are doing is we are measuring how much the plants really need onto light, and from there on we can dynamic control the light and how much light the plants really need. And what else are we doing? Yesterday we initiated a kind of project we would like to tell about today. So maybe you had the chance to follow the presentation of my colleague yesterday from Fraunhofer UMSICHT, which is very much into agrophotovoltaics. And we like to combine modern cultivation technology with the energy and the water demands for island regions, maybe on the Canary Islands. So if you are interested to share, we are open for cooperation, for capacity building. Please contact my colleague, Mr. Schicko from Hard Techno. I think he will coordinate this project for the future prospects. And with this, I hope into time. Thank you very much. Yes, for questions, I'm open.